Imagine a hidden ocean, buried beneath kilometers of ice, where radioactive particles might be generating enough energy to sustain alien life forms. Today, NASA launched the Europa Clipper spacecraft, embarking on a journey of 3.2 billion kilometers to investigate whether Jupiter's moon Europa could harbor life. What might scientists discover as they probe this mysterious frozen world? The answer could forever change our understanding of life in the universe. The mission that could change everything, NASA's Europa Clipper. On October 14, 2024, NASA took another giant leap in the exploration of our solar system by launching the Europa Clipper spacecraft. This mission, which could mark a turning point in the search for life beyond Earth, is headed to the intriguing moon Europa, one of Jupiter's many natural satellites. With over 3.2 billion kilometers to cover, the spacecraft will take 6 years to reach Europa. However, when it finally arrives, its discoveries could profoundly reshape what we know about habitability on other worlds. What is Europa Clipper and why is the mission so important? Europa Clipper is an impressive spacecraft. Weighing about 6 tons, it carries 9 advanced scientific instruments, including high-resolution cameras, spectrometers, and radar systems. Each of these tools is designed to uncover the mysteries of Europa, a moon covered in ice that is thought to have a vast underground ocean, possibly larger than all of Earth's oceans combined. For the scientific community, this mission could answer one of humanity's most profound questions. Are we alone in the universe? Europa has always fascinated astronomers. Since the first images captured by earlier probes like Galileo, scientists noticed that Europa's surface has far fewer craters than other moons of Jupiter, suggesting a young and dynamic geological activity. But what intrigues them the most is the thick crust of ice covering the satellite. Beneath this frozen layer, there is evidence of a liquid ocean, a place shielded from the harsh conditions of space, where water and possibly energy exist. These are the critical ingredients for life as we know it. The launch and the Falcon Heavy rocket. Europa Clipper's launch took place at NASA's Kennedy Space Center in Florida at 1:06 p.m. Brasilia time. Originally scheduled for October 10th, the launch was postponed due to strong winds caused by Hurricane Milton, which had swept through the region just days before. When it finally lifted off, the spacecraft rode into space atop the Falcon Heavy, the most powerful operational rocket built by SpaceX. The Falcon Heavy is renowned not just for its ability to carry heavy payloads into space, but also for its innovation in reusing rocket components, making space missions more financially feasible. The successful launch of Europa Clipper highlights the growing importance of public-private partnerships in space exploration, with SpaceX playing a crucial role alongside NASA. The journey to Jupiter and gravitational assists. However, the path to Jupiter won't be direct. To conserve fuel and utilize physics to its advantage, Europa Clipper will perform a maneuver known as a gravitational assist. The spacecraft will first pass by Mars and then swing back towards Earth, using the gravity of these planets to gain speed and momentum. This process is essential to ensure that the spacecraft has enough energy to reach Jupiter and successfully complete its scientific mission. These gravitational assists are a brilliant example of how modern space exploration combines human ingenuity with the basic physics of the universe. By stealing a small fraction of a planet's gravitational energy, the spacecraft can change its trajectory and increase its speed, saving massive amounts of fuel and extending the mission's lifespan. Why is Europa so special? Europa, with a diameter of about 3,100 kilometers, is slightly smaller than our moon. But what makes it special is what lies beneath its icy crust. Estimates suggest that Europa's ice layer is around 100 kilometers thick, with a mixture of solid ice on the surface and potentially liquid water deeper below. If confirmed, the amount of water in Europa's ocean would be staggering, almost double the total amount of water in all of Earth's oceans combined. This ocean is shielded from space by the ice layer, which means it could be a stable, chemically dynamic environment, potentially offering ideal conditions for life to emerge. One of the main questions the Europa Clipper will seek to answer is whether the moon has the essential chemical elements, such as carbon, oxygen, and nitrogen, as well as enough energy sources to sustain living organisms, even if only microbial. Additionally, Europa's interaction with Jupiter's intense magnetic field generates a thin atmosphere composed of oxygen, though this oxygen does not originate from biological processes as it does on Earth. Jupiter's radiation breaks apart water molecules on Europa's surface, releasing oxygen. This process could be crucial for the potential habitability of the underground ocean, as the released oxygen might seep into the water, creating a chemically interesting environment for life. Radiation challenges and NASA's ingenious solutions. One of the biggest challenges facing the mission is the intense radiation that Europa receives from Jupiter. It's estimated that radiation levels on Europa's surface are so high that any spacecraft exposed to it for too long would have its electronics fried within hours. This is because Europa lies within Jupiter's powerful magnetic field, which captures charged particles from the Sun and accelerates them around the planet. To overcome this obstacle, NASA engineers designed Europa Clipper with a range of protective measures. The most important is a specially reinforced aluminum box that houses all the spacecraft's sensitive electronics. Known as the radiation vault, this shield should ensure that the Clipper's instruments continue functioning even during close flybys of the Moon. Moreover, Europa Clipper won't orbit Europa directly. Instead, it will orbit Jupiter and conduct 49 close flybys of the Moon, each at carefully planned intervals. This strategy minimizes the spacecraft's exposure to radiation while still allowing it to perform detailed measurements. Each flyby will expose Europa Clipper to an amount of radiation equivalent to 1 million chest X-rays, but the spacecraft is designed to withstand this level of exposure. What does Europa Clipper hope to find? Scientists have high hopes for what Europa Clipper might discover. One of its primary tasks will be to use its radar instruments to map the structure of Europa's ice layer and search for evidence of liquid water beneath. If the existence of a subsurface ocean is confirmed, it would strengthen the hypothesis about Europa's potential habitability. The spacecraft will also look for organic compounds, the building blocks of life, and signs of geological activity, such as ice volcanoes, which could indicate ongoing chemical processes in the subterranean ocean. Additionally, Europa Clipper will study Europa's thin oxygen atmosphere and investigate how it interacts with Jupiter's magnetic field. The broader implications of the mission. If Europa Clipper finds evidence that Europa could support life, the implications will be profound. Not only would it bolster the hypothesis that life can exist elsewhere in the solar system, but it would also expand our understanding of habitable environments on planets and moons beyond Earth. This would open doors for future missions, including the possibility of sending probes that could drill through Europa's ice and explore its ocean directly. However, even if the mission doesn't find direct signs of life, it will undoubtedly provide an unprecedented amount of data about one of the most intriguing locations in our solar system. This information will guide future explorations, not just of Europa but of other icy moons like Enceladus, which also shows signs of harboring a subsurface ocean. Conclusion. With Europa Clipper now on its way, humanity is closer than ever to answering the age-old question: are we alone in the universe? By 2030, when the spacecraft reaches Jupiter, science will be ready to unlock the mysteries of Europa, a moon where the conditions for life might be hidden beneath a crust of ice. Until then, the spacecraft and its engineers on Earth will continue to work toward ensuring the mission's success, keeping alive the hope that soon, we may have an answer. If you enjoyed this video, don't forget to like, share, subscribe, and hit the notification bell to stay updated. Thank you for watching.